Next, we'll write a script to interact with a smart contract. If you recall from our previous example, we'll be following a similar steps here. We'll set up a local blockchain. We'll set up a salt argument, which is new this time. We'll set up a few accounts that will need to deploy our application. We'll set up an instance of our zkApp, and then we'll make a few transactions to test our zkApp. We'll start by setting up the index.ts file here. In this, we'll include 2 lines of code that will import and export our smart contract code. Then we'll move on to the main.ts file, which we'll use to interact with our zkApp. We'll start by importing our private input smart contract code. Then we'll do some other necessary imports from o1.js. Then, similar to our previous example, we'll set up a local instance of Mina blockchain, and we'll also set up the private keys and public keys for 2 accounts, which is the deployer account and the sender account. Here we'll create a random salt variable. In this section of our interaction script, we'll set up our zkApp. We'll create a random private key for our zkApp, just like we did in the previous example, and we'll derive a public address from it. We'll then set up a zkApp instance by sending a transaction from our deployer account, indicating that we want to fund the creation of this zkApp from our deployer account. We'll then deploy our zkApp instance and we'll initialize its state by passing in our salt argument and a random value 750 that would act as our first secret value. We'll wait for the proof to generate and we'll sign it off with the deployer key and the zkApp private key and send it over as a transaction to the Mina network. Once our app is set up, we'll fetch the value of x and we'll print it. So let's see how this goes. If you recall from our previous example, we use this command npm run build and node build src main.js to build a smart contract and run our interaction script simultaneously. So you'll see that our smart contract was built, our zkApp was set up, and here we'll see the value of x after initialization. This is the Poseidon hash value of our secret argument and the value 750 that we passed as a first secret value. Now we'll make the first transaction to our zkApp. We'll send this transaction from a sender account. We'll call the increment secret function within the zkApp and we'll pass in the salt argument and the value 750, which we know we passed as an initial value of our secret field. We'll wait for the proofs to generate and then we'll sign it with our sender key and send it over to the Mina network. Once the transaction is successful, we'll fetch the value of x again and see what it is. Let's run it once again. So our smart contract was built, the zkApp was initialized, our x was initialized, and after first transaction, the value of x changed. You'll see a difference in the hash values here. This is the Poseidon hash value of our salt argument and the value 750. Since we passed in the correct secret field value, this is the Poseidon hash value of our salt argument and value 750 plus 1. Now let's do a second transaction. In this transaction, we'll pass in the wrong secret value and see if it fails or not. The way of making a transaction is similar, and we'll see how it goes. So again, smart contract were built, zkApp was set up, an initial value was set. In our first transaction, we change the value, and then in the second transaction, we see the assert statement failing. This is because we passed in the secret value as 800, which is not the current secret value of 751. So you'll see the state after transaction 2 remains unchanged.